Good afternoon. First of all, I would like to welcome all of you to this session. My name is Uthman Omran Khalifa. I'm going to present this paper on behalf of my student. The title of my presentation, Wireless Power Transfer for Ethical Video Charging. This is my presentation outlines. I'm going to give some introduction about the topic. Also, I'm going to highlight the motivation and will present the related work. Also the methodology and proposed solution will be presented, and also I'm going to show the results and discussion, and I'm going to end up with the as you know that we are living in the century of technologies, and everything all must become automated and intelligent, and wireless power transmission is expected to be widely used in many modern applications. The principle of the inductive wireless power transmission charging has two parts of the inductor. One part of the inductor acts as the primary winding, and the other part, or the other half, acts as the secondary winding transformer. And the role of the chargers to convert the low frequency AC power to high frequency AC power. And the high frequency AC power transmit from the charger to the secondary side and convert to DC power. In case of the electrical vehicle charging, there are three essential requirements to be effective and suitable for charging, and which is the air gap, high power, and high efficiency. The major drawback of the traditional battery charging nowadays, the use of the plug-in charging devices. While in wireless power transmission, could increase the device mobility, avoid wiring, reduce the maintenance cost and isolation, and also could improve the electrical vehicle's reliability. No emission also. I think electric cars are almost 100% eco-friendly and could reduce the noise pollution. Of course, as I mentioned earlier, the application of wireless charging has many applications where the chart or smartphones, portable media, accessory can be used. Also could be used in public access charging terminal, computer systems, cabinet automated applications, electric vehicles, and others. Also, the wireless power transmission could be categorized to four types, which is inductive coupling, magnetic resonance inductive coupling, wireless power transmission using microwave, and also power can be transmitted also by laser. In this work, we're going to use the inductive coupling wireless power transmission. And this is just comparison between these methods, and in terms of distance and efficiency, and you can see some of them for a few millimeters, and some of them go to up to 100 kilometers, and you see the efficiency also with low and high. This is the major component of the wireless charging systems. I think this is very general one. You can see from transmitter here, and of course we're going to have the control for the transmission, and the medium for the communication go up to the second or secondary coil, which is the receiver also. Also can be battery for charging as well. This is the some of the related work. Of course, there's a lot of work really, but just I'm highlight a few here. And the oldest one by Nicholas Tesla, which is 1882, and also the latest also 18 also. And just I'm showing here the limitations starting from that era where they stop finishing until the end with the result narrow to very rectifiers. What is the proposed design? Just we assuming that we're going to use toy car or small car with the coils here, primary and secondary. And this is actually the most challenging part, which is the coil design and alignment. And this is the system flow chart. Start from standby transmitter, by the air, and then on the alignment, so on. And this is the circuit that was used. So this is the schematic diagram. This is the primary, and this is the secondary. This is the sum of the results. So in this work, we constructed circuit with the separate transmitter, and we used the toy car here. You can see here, coil, transmitter, and coil with different orientation, different distance, and different alignment. Just a few results being shown here. You can see here the output current and the output voltage, output current, output voltage, based on the distance here. You can see from 10 meter, 10 millimeter, 20, and so on. So with this is 10K for the load, assume the car, and this is for 20K kilo ohm, and this is for 40 kilo ohms. And this is showing some of the oscilloscope result using the experimental work. This is the conclusion. So in this work, we proposed a circuit for wireless power transmission system, and the most challenging part was the coil design. It's extremely critical, and the challenge was the misalignment also, which plays a major role in the power transfer. However, the inductive or dynamic inductive power transfer method is proposed, and a few simulation experimental results were conducted as well. And we achieved it actually based on the alignment around 90%, as you see. So that's it. Thank you very much. Waiting for your comment and questions.